Here are my 10 hardest questions in P2. So here are my 10 questions. In past exams, 40% of the questions have been maths questions. So I've put a lot of maths questions in here. It's going to be combining equations. These are tricky. In the exam, they'll probably break it down a little bit more for you than I have here. But these are designed to be really, really challenging, testing, hard questions for you. If you get these right, then you're doing absolutely fantastically well. 10 questions here. I've done it 6 mark per question, so it should take you about an hour to do these. You can pause here if you want to have a go at these questions and then check your answers with my working, or you can just work straight through it with me. So if they gave you this question, they would probably give you a graph to go with it. This is going to be quite a wordy question, so I'm going to write it out and then come back to you in a second. So here's my answer, and this is a really tricky question because there are lots of different parts to it. You need to know quite a lot of things. I'm not going to talk you through it because you can all read. I'm just going to leave it out there and say that 6 points here. So 6 marks. If you got a few other points but they're relevant, feel free to pop them in the comments and ask me and check. So here we have a very nice maths question. So a climber has a mass of 75 kilograms. Climbs to the top of a cliff. This is going to be a distance or a height or an extension, and jumps off, find the velocity. And before we start doing that, I just want to bring your attention to these over here. These are my rules for answering maths questions. I have marked a lot of maths questions, and I think these are a really, really good way to actually do the maths questions. So if you're a bit stuck with maths, which is about 40% in P2, it's a lot. And check out my questions, my videos where I talk you through how to do loads and loads of maths questions. So this is a tricky question because I'm actually asking you to combine 2 equations here. A climber who has a mass of 75 kilograms climbs the top of a cliff and bungee jumps off, find her velocity. So in an exam, they would probably break this down into a couple of parts for you. But the first equation I want you to use is for gravitational potential energy, which is mass times gravity times height. So we have mass, that is 75. Gravity, you should remember, is 10. Chances are they'll tell you it's 10 in the exam, but they may or they may not tell you that. So it's always worth remembering that. And then we have the gravitational potential energy, which is 1.12555 joules. Now it's really, really important that you remember your units because the examiners are not going to tell you your units in the exam. Now we have our joules, we can take that and then we can work out the kinetic energy, which is going to be half mass velocity squared. There are a couple of ways you can do it. You can rearrange the equation first, or you can put the numbers in first. I personally like to put the numbers in first. So we have 500, which is our energy here, and then we have half times mass, which is 75 times velocity squared. So what we need to do is to just rearrange this equation a little bit. So velocity squared equals 3000, and then to get velocity we just need to square root that, so it's going to be 55 meters per second. Really tricky question there. In the exam they would definitely give you a bit more hint and a bit more help, but I did say these were going to be hard questions. So I'm going to give you 1 mark for each of your each of your equations there. 1 mark for the working, 1 mark for the units, and again 1 mark for the working and 1 mark for the units. It's really, really important you learn your units. So So this is a tricky question. It's actually quite a lot to remember here. But stars starts off as protostars. These are large clouds of dust and gas in space, which all come together under the strength of its own gravity. They then go on to form a main sequence star. That is where our sun is at the moment, and because here we're talking about a star that is bigger than our sun, it's going to become a red supergiant. After it's been a red supergiant, it's going to undergo supernova, and then can go on to do one of two things. It can be a neutron star, or it can be a black hole. Now, I see this asked as a 6-mark question, and unfortunately you're not just going to get 6 marks for writing down a long list of things, so you need to add a few bonus things in. So in a main sequence star, this is where all the forces are balanced. Supernova, this is where the fusion of heavy elements takes place. And the presence of heavy elements on Earth is how we know that our sun is actually a second generation star. So we underwent supernova at some point in the past. Heavy elements are formed. The supernova exploded into a new protostar, and then everything coalesced again to make a second main sequence star. So our sun is actually really quite small in comparison to the majority of stars out there. And there is a difference in mass between black hole and a neutron star. So black hole is going to be the really high mass ones, and neutron stars are going to be slightly lower mass ones. In the supernova, it expands and contracts several times. And this is where the fusion is going to take place. So I'm going to give you 4 marks for coming up with the actual sequence, and then 2 marks for any of the added information that you put in there for me. So this isn't necessarily a tricky question, but there's quite a lot of information going on in here, so I thought I'd put it in because there's quite a lot to remember. So I'm just going to draw this as a table. It is possible they'd ask this as a 6-mark question. I don't think it'll be very likely. If they did ask it, it'll be something a lot more specific, and they like to have things with a lot of context in P2. So I don't think this will be a 6-mark question, but it's quite a lot to answer here. So the first thing you need to know, I'm going to do series circuits. So the total current is the same all the way through. So through each component, the current is going to be the same, and the resistance is going to be the sum of everything. So the sum of all the resistance of all the different components in there. And lastly, for series circuits, that the potential difference of all of the individual cells is going to add up to be the source of the source potential difference. So parallel circuits are slightly different. When things are connected in parallel, it's going to be the current is going to be shared between all of the branches, or the different pathways that it can take. And the potential difference is also different because it's going to be the same across each branch. I should have put over here that in a series circuit, just like the resistance, the potential difference is all added up, so different to the parallel circuits. And this is quite a short question, so I can only think of 5 things for this. So just give yourself a mark for each of those, and then because I said it was going to be out of 60, you can just have an extra mark. So this is a momentum question. This is a really, really tricky question if it comes up. This is a very realistic sort of question. They might give you a picture to draw. So that's exactly what I'm going to do here. So this is Sophia travelling one way, and this is Nisha travelling the other way. And I'm just going to say that this side is positive and this side is negative, because I've given you a velocity here, but there's a numerical value to the velocity. Remember, velocity is speed with a direction. So this has a mass of 47 kilograms. This has a mass of 68 kilograms. We are travelling this way with a velocity of plus 7.2 meters per second, and then we're travelling this way with a velocity of minus 4.8 meters per second. This is minus because she's going this way, and I've given this the minus direction. This one's positive because she's going this way, and I've told us this is the positive direction. In reality, it really doesn't matter which way you say it's positive and which way you say it's negative. It's conventional to do it this way around, but if you want to do it the other way around, it's absolutely fine, just as long as you make it very, very clear to the examiner what you've done. So these two, I'm going to call them blobs, meet, they become one big blob, and then they travel off together. So this is our before situation. I'm just going to draw a line down here. This is before, and then we're going to have after. So we know the mass of our blob after, because it's just the masses of the two of them added together. So that is 155 kilograms. Now, because of the law of conservation of energy, we know that our momentum before is going to be exactly equal to our momentum afterwards. So momentum equals mass times velocity. So you need to work out the two different sets of momentums and then add them together. So 47 times, that needs to be 47 times plus 7.2, and then 68 times minus 4.8. So I worked out the two individual velocities. I'm just going to add the momentum, sorry. I'm just going to add these together, and that is going to equal plus 12 kilogram meters per second. So that's my momentum 4. We know that is going to be exactly the same as the momentum afterwards. So I know this is going to be plus 12. I know this is 115, so I just need to find my velocity. So I do plus 12 divided by 115, which equals plus 0.1 meters per second. So I've given you the velocity, and the plus tells us the direction, because I've said that plus things are going in this direction here. In the exam, it'll be it'll be a good idea for you to say it's going to the left hand side or it's going to the right hand side as well. So this is a really tricky question. It'll probably be broken down into a couple of parts for you. I'm going to give you 1 mark for the equation, because I didn't mention momentum in the questions, so it would have been quite tricky for you to work that out. I'm going to give you 1 mark for working out each of the individual momentums and then working out the overall momentum. Then 1 mark for telling me the direction and 1 mark for telling me the final answer. So this is a particularly mean question, just because in the exam they wouldn't give you this many to do in a row. They'd probably just ask you to do 1 or 2. but like I said, I'm being particularly mean. So starting off with lead 82, and we're taking away an alpha particle from it. So that is 42, and we are going to end up with 20380. And to do this, you're going to need a periodic table. If they ask you to do this in a physics exam, they will give you the information. They won't give you a periodic table, a full periodic table, but they won't expect you to remember it. So we've done one alpha, so we're going to take away another alpha particle here, so that makes 19978. So now we are platinum. Taking away a beta, I'm just going to rewrite this down here because I like things nice and ordered. So beta particle has no mass, but it has -1. So we go to 199 minus 1 is 79. So that is going to make it gold. We take away another alpha. That will be 19577. 77 from our periodic table is iridium. That's alpha. Again, I'm just going to write this down here for my purposes, and then we're minusing a beta at the end. That's a 0. And then we end up with 19578, which is platinum. So I just want to point out to you that we have platinum here and we have platinum here. These are isotopes of each other. So they have the same atomic number but a different mass number. So I'm going to give you a mark for each of these. So 1, 2, 3, 4, 5 and 6 if you manage to get all the way to the end. This is really, really hard. They would only give you 1 to do at a time. They might give you 2, but it's not really any harder doing a number of these in a row. It just gets a bit complicated. You just have to keep track of things and do it carefully. So the really important thing you need to remember here is, or pay attention to here, is whether you're drawing a velocity time graph or a distance time graph, because they look very similar, but they are actually very, very different. So Primrose leaves her house and travels for 5 minutes at 3 meters per second. So she's going to be travelling at constant velocity for 5 minutes. She then pauses, so that's going to be coming all the way back down here for 1 minute, so her velocity was 0. She then spots a bird and spends 2 minutes chasing it at 5 meters per second, so we're going all the way back up here. And once she has it, she spends 3 minutes dragging it back home at a rate of 1.5 meters per second. So we're all the way back down here for 3 minutes. And then we get there. Now, this is a very quick sketch of the graph. If she was accelerating, that's when it would be a sloping line on the graph. Now we work out the distance by the area under the graph. So I'm just going to label these bits A, B and C, just because that's the way that I like my students to do it. And then the first one is 5 times 3, so that equals 15 meters. And the second one is 2 times 5, so that bit there equals 10 meters. And then this is 3 times 1.5, so that equals 4.5 meters. Add all of those together, and she has travelled a total distance of 29.5 meters. So I'll give you 1 mark for sketching the shape of the graph properly, and then 1 mark for working out all of the different distances. So another maths question here. This is about Hooke's law. So the equation we need for Hooke's law is force equals K times E, where this is our force measured in newtons, this is our spring constant, and that's going to be particular to the spring. That is measured in newtons per metre, and this is our extension, and that is measured in metres. So here I have a force, and here I have my extension. But you notice the extension is in centimetres, so the first thing I need to do is convert it into metres, and that is dividing it by 100, so that is 0.62 metres. It's really, really important that you take notice of your units, and if necessary convert them into standard units. So I'm just going to plug my numbers into the equation here. 62, so 4 divided by 0.62 equals k. So that is going to equal 4 divided by 0.62 equals 6.45 as the spring constant. Now Hooke's law says that for an elastic object it will be directly proportional up and to the point where it's not. So this here is the maximum force that can be applied. This is a point past where it becomes inelastic. Up until that point, force and extension are proportional to each other. So I'll give you 1 mark for the equation, 1 mark for the working, 1 mark for the answer, 1 mark for the units as always, and then I'll give you 1 mark for explaining that this bit is directly proportional only up to a limit. So this is a particularly nasty question. The first thing I'm going to do, as always, is just circle all of my numbers here. So this is the velocity. Here I have this one. This is a force, and here I have a distance. And you can see that we need to work how much force needs to be applied to the brakes. So it's a bit confusing. This is force in the question. So you might think that's just the answer, but there's quite a lot going on here. So the first thing what we need to do is to combine 2 equations here. So first of all, we have a speed, a force, and a distance. This might take you a while to work out, but what we need to do, the final equation we need to work up with is work done equals force times distance, and this here is in joules, this is in newtons, and this one is in metres here. And because work done is in joules, we can use the equation for kinetic energy, half mass velocity squared, to work out the work done. That's in joules, that's in kilograms, and that is in meters per second. But you'll notice that I've been particularly mean to you and just given you the weight. So you need to know that weight equals mass times gravity. Gravity being 10, weight is in kilograms, and mass in kilograms, and weight is in newtons. So we need to do quite a bit of backwards calculations. First of all, we need to work out the mass of the car from the number of newtons. So we have weight equals mass times gravity. That is 1,200 equals mass times 10. So the mass is equal to 120 kilograms. Then we have the kinetic energy equals half mass velocity squared. So that is half times 120 times 27 squared. So the kinetic energy is 43740 joules. We can now pop that back into the first equation we had, which was work equals force times distance. So work done and kinetic energy are both in joules, so we know that the work done by the brakes is there. The force is what we're trying to find, and the distance travelled we've also been given. So we need to do a bit of rearranging of this equation here, which equals 257 newtons. Really nasty question though. If you manage to get that one correct, well done. So a ridiculous amount of things going on here. I would give you 1 mark for each of the equations there. I'll give you 1 mark for working out the mass, 1 mark for working out the energy, and then 1 mark for working out the force. Should really be worth a lot more marks than this, but I said 6. So previous to Rutherford and Marsden's experiment, we had a plum pudding model of the atom where they thought that it was a bit like a solid billiard ball with random negative and positive charges dotted all the way through it. Rutherford and Marsden did an experiment where they had a sheet of very fine gold foil and they fired alpha particles at it. And what they found is that while some went straight through, some were deflected. And some were deflected a little bit, and some of them were deflected really quite a lot, which was confusing considering they were expecting it to be just a big solid ball all the way through. So they came up with a nuclear model of the atom, which basically means that they think the inside is solid, and then all around the outside is basically made up of empty space, which is exactly correct as far as we know for the model of the atom, that we have the positive nucleus in the middle, and then effectively just a lot of empty space around the outside. So for this, your 6 marks are going to be for explaining the plum pudding model, 1 there, 1 mark for explaining the experiments, and that's 2nd mark for saying that most of them went through, 3rd mark for saying some of them reflected. And then the rest of the marks are going to come from explaining the nuclear model of the atom, the fact that there's a very small positive nucleus and a large amount of empty space. And the nucleus must have a positive charge because the alpha particles with a positive charge were being repelled by it. Thanks for watching. I really hope this is helpful. Subscribe so you don't miss any of my new videos. Share to help your friends get better grades. Any comments, corrections, questions or requests down below please.